Hi everyone, welcome back to functional swing plane. Today's part 2. And before we start part 2, here are the videos included in the Golf Biomechanics playlist. Among these, I strongly recommend you to watch the swing events and phases and also functional swing plane part 1 first, if you have not. And then I also have some additional videos in the category of force and torque. Okay, so let's continue the topic of functional swing plane. Let me first have a brief recap of what we did in part 1. So the definition of the functional swing plane here. The functional swing plane is basically the plane calculated from the club head trajectory from the mid downswing to mid follow through. So if you use this club head trajectory, then you will be able to find a well-defined plane. So here, as you can see in this view here, this is the club head position at the mid downswing, and this is at mid follow through. And then, as you can see here, the trajectory actually forms a clean plane. So you can, by using the trajectory here, mathematically, you can compute the plane, which is the functional swing plane. And then once you compute the swing plane, then you can extend it here and then see how the club head is moving relative to the swing plane. So it will show some deviations here, but the club head will quickly come down to the swing plane on the way down. But anyways, again, remember that the functional swing plane is calculated from the club head trajectory from the mid downswing to mid follow through. And then the motion of the club head and also the hand center can be divided into two components: the on-plane motion and the off-plane motion. So here, this is the actual trajectory of the club head. This is the actual trajectory of the hand or the hand center. And then this thin line here is the projected trajectory on the swing plane. And this is also the projected trajectory of the hand on the swing plane. So by using the projected trajectory, we'll be able to see how the club head is moving on the plane. And then by using the deviation of the club head or the hand center from the swing plane, we can also describe the off-plane motion of the club head and the hand center. So depending on the swing style, in some cases, the club head will quickly move toward the swing plane on the way down early on. And then the club head stays fairly close to the swing plane here up until mid follow through, and then it will start moving away from the swing plane to late follow through here. So by looking at the off-plane motion pattern of the club head with respect to the swing plane, we can actually classify the swing styles. And this will be, again, revisited in the next episode. But anyways, basically by using the swing plane, we can basically describe the motion of the club head and the hand center, in the perspective of on-plane motion and the off-plane motion. And in terms of the on-plane motion, the most fundamental pieces of information that we can get from the swing plane is the slope and the direction of the swing plane. So in this one here, here's the swing plane here. So this is basically calculated from the club head trajectory from mid downswing to mid follow through. And then if you extend this plane all the way to the ground here, then this line is the functional swing plane ground line of intersection. And also, if we use the top view, then again, this line is the line of intersection between the swing plane and the ground. So with this, the first information that we can extract from the swing plane is the slope. So the angle between the functional swing plane and the ground. And then we can also measure the direction angle here. So the direction of the swing plane relative to the target line here. And the direction can be either outward or inward. So currently, this swing plane is basically pointing the right side of the target. That means this swing plane is slightly outward. But in some cases, you can have an inward swing plane as well. So basically, we'll be able to describe the direction angle with the directional terms like outward or inward. So once we have the slope and the direction angle, then we can easily characterize the swing motion of the golfer. So the slope and direction angle are important pieces of information. And then in terms of the slope of the swing plane, so we have three different cases here. The middle one shows the average slope for given height here. So currently, this golfer shows a swing plane slope of 47 degrees, which is the expected slope. So this is the average value. And then we have two extreme cases here. This one shows a steep swing plane. So the swing plane is basically passing through the middle section of the upper trunk here. And then this one showing the opposite extreme. So this is the flattest. Now the swing plane is passing through the middle section of the lower trunk. So actually the slope can vary quite a bit depending on the golfer and the swing style. And then the reason why we see this kind of variation in the slope of the swing plane is the swing style here. So the middle one basically uses a body-driven swing. So in that case, you have active lower body action here. And with that, the swing plane generally passes through the midsection of the trunk here. When you have a steep swing plane, that means that this is quite arm-driven. But as you can see here, the club head is here at the top of action. But as the downswing starts, the club head will move up here and then come down here. That means you are letting the club go away from the body early on. This is because this is arm-driven swing. And then in the arm-driven swing, the club starts moving relatively faster early on. So it's hard to introduce a motion in this direction here. That's why it just has to use a steeper swing plane like this. And then in the flat swing plane here, this is because the pelvis is collapsing. And it is mainly coming from this bent knee here. If you keep your knees bent all the time throughout the swing, that means you will not be able to push the ground that well. So in that case, you naturally have a flatter swing plane here. So basically, the slope reflects the swing characteristics of the golfer. So the slope is basically a function of swing pattern. Now here's some data here. So this is from 63 elite male golfers. Elite male golfers means either tour players, then teaching professionals and college players. But so when we look at when we combine the 63 golfers and then compute the average slope for the driver condition, it's about 48 degrees, so slightly less than 48, so 47 point something. But as you can see, it has a wide range here. The steepest is 53 degrees, and the flattest is about 43 degrees. 5-iron, the average slope is 57 degrees, so it's definitely steeper than the driver. And then again, the range will be 63 degrees to 50 degrees. So it has a wide range here as well. Pitching wedge, it gets even steeper, 61 degrees on the average. And then the range is 56 to 66. So as you, what we see here is as the club gets shorter, the swing plane gets steeper. And another important information that's included in this table is the correlation of the slope to the height of the golfer. So these values show positive correlations. That means the taller the golfer is, the steeper the swing plane is. And they all show significant correlations, actually strong correlations here. So what I did was I tried to develop a sort of a prediction equation using the height of the golfer. So here are the equations. So for the driver, the average slope in degrees is equal to 0.249 times the body height of the golfer in centimeters plus 2.4. And that means for every 4 centimeter increase in the height, we will see a 1 degree increase in the slope. So 4 centimeters of height is equivalent to a 1 degree of slope. So that's what we see here. For the 5-iron, it is equal to 0.206 times the body height plus 19.6. So if you look at this slope here, it's close to 0.2. So for every 5 centimeter increase in the height, we see 1 degree increase in the slope in the 5-iron swing. And then pitching wedge, it will be 0.188 times the body height plus 26.5. So for every 6 centimeter increase in the body height, we see 1 degree increase in the slope. And then these basically show the average slope. And the average slope generally passes through the elbow here. So essentially the slope we get from these equations will be basically the plane that passes through the elbows here. So using these equations, what we can do is, for example, if the height of the golfer is 180 centimeters or 6 feet, then if you put this value in these equations, then the expected or the average slopes are the 47 degrees for the driver, 57 degrees for the 5-iron, and then 60 degrees for pitching wedge. So we can compute the expected slope or the average slope of the golfer for a given club condition. But then the actual slope can be steeper than these values or flatter than these values. Again, that is determined by the swing pattern of the golfer. So whether it's body driven or arm driven, or whether the pelvis collapses in the downswing. And then I tried to include some other factors in the regression equations here, but I could not find any factors that yielded significant results. So although some people tend to relate the slope of the swing plane to, for example, the length of differential between the segments or the arm span and things like that. But when I include all those, I did not see any significant effects. So the body height is the dominating factor, the dominant factor, and all others generate the non-significant effects. So it really depends on the swing style of the golfer. Okay. So, but at least we know that the slope is basically a function of the height of the golfer. Then let's move on to the direction of the functional swing plane. Again, this is based on 63 elite male golfers. And on the average, in the driver swing, the direction of the swing plane was 1 degree outward. But it has a fairly, again, large range here, 7 degrees inward to 9 degrees outward. And then the 5-iron pitching wedge, these are fairly squared. So these are aligned toward the target. So 0 degree on the average. But still, it has a fairly wide range here. So what we can see here is that the driver swing tend to have a slightly outward average direction angle, but the iron conditions basically show that the swing planes are more aligned toward the target here. So these are the facts we can observe. So here are the two extreme cases here for the driver swing here. So this shows a 7 degree inward alignment. So this is the swing plane here. It's way inward relative to the target direction. And this one is 9 degrees outward. This angle is 9 degrees here. So these are the extreme cases. And at impact, as you can see here, the arrow, this red arrow shows the direction of the club head motion at this instant. So this arrow is not quite along the swing plane. So it's somewhere in between the swing plane and the target direction here. But this is because this golfer uses the down below. So the impact occurs when the club head is moving downward. This is a driver condition, but this golfer is actually using down below. And then in this case, the golfer uses up below. So this is the direction of the swing plane. This is the target direction. And then the velocity arrow of the club head at impact shows somewhere in between. Again, this is because it's using up below. So the club head is hitting the ball on the way up. So this angle reduces slightly. But still, in both cases, this arrow and this arrow are not exactly aligned toward the target. That means you have to use a side spin. So in this case, you have to use a fade to bring the ball to the middle of the fairway. In this case, you have to use a draw spin to do that. So when the velocity, the direction of the club head velocity at impact does not match to the target direction, then you have to use a side spin to bring the ball toward the center of the fairway. And here, one thing I want to direct your attention to is how the direction changes depending on when the impact occurs. Okay. So here's the impact position and the attack angles. The left one shows the vertical attack angle. What this means is that the angle between the club head velocity arrow and the horizontal line. So the middle one shows the leveled impact. So actually the club head is at the low point of the trajectory. So at this point, the club head is moving horizontally here. So if the impact occurs at this point, then the vertical attack angle will be 0. And then when that happens, the direction of the club head motion is the same to the direction of the swing plane. However, if you have a down below, because the impact occurs before the club head reaches the low point, then you will have a slight down below. Then you have a negative vertical attack angle here. And then with that, you will have more outward motion of the club head at this point here. And then when you have an up below, that means you have positive vertical attack angle here. Then on the horizontal plane here, the arrow is more toward the left side of the target, or left side of the swing plane, the direction of the swing plane. So it will show more inward motion of the club head at impact. So although the swing plane is toward the right side of the target in this case here, but depending on when the impact occurs, whether it's a leveled impact or up below or down below, then the actual direction of the club head motion changes slightly. And in the driver swing, we tend to have an upload, for example. So if it's upload, then the horizontal attack angle shows more inward direction relative to the swing plane here. So if you want to match this to the target direction, then you have to shift the swing plane more outward. But that's why we see the tendency of more outward swing plane in the driver condition. But for the iron condition, it's fairly close to, although it's down below. We typically say it's down below, but it's close to a leveled swing. So the swing plane is more aligned toward the target. So the actual direction of the clubbed motion depends on where the impact occurs. So we have to consider these in addition to the direction of the swing plane. Okay, so in this episode, mainly looked at the slope and the direction of the swing plane. And we'll continue this discussion for a while. So expect more episodes on the function swing plane. Thank you for your attention.